Now, it'd be great if you could just pause here and try this one out. I'm going to go over it right now, though. So again, using that fundamental root theorem, we check factors of the last number, which in this case are 20, over factors of the first number, which our leading coefficient is 1. So we don't really need to draw markers. It would be over 1, so it wouldn't change. So really we're just looking for the factors of 20, which could be positive or negative 1, 2, 4, 5, 10, and 20. So 1, 2, 3, 4, 5, 6, two versions, positive and negative. So there could be 12 things that we're testing out here. Let's set up our synthetic division. 1, 4, negative 1, 16, negative 20. We're going to need a positive 20 over here somehow. I'd be really surprised if we'll try one. We'll see if that works. So let's try out 1. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 1 plus 5 is 4. 1 times 4 is 4. Plus 16 is 20. Ooh! 1 times 20 is 20 plus negative 20 is 0. Sweet. So we can draw on our video. Oh, silly Mr. Such a silly Billy. Okay, that's on there forever, I guess. Okay, what is happening? Is this real life? So one of our zeros is positive 1, which we would write that as x minus 1. Okay, now we need to check another set here. Bring down our 1. Now look, we're going to need a negative 20 over here. So we need to somehow turn these negative. We're going to choose one of our negative things. You can choose 1, you could choose 2, you could choose 4. You know, if you threw these into a graphing calculator or like Desmos.com, it would give you a graph and it could give you like some pretty close estimates of what the zeros are, and you can use that. But you're cooler than that. So let's try like negative 4. So 1 times negative 4 is negative 4. 5 plus negative 4 is 1. Negative 4 times 1 is negative 4. Plus 4 is 0. 0 times negative 4 is 0. So that won't cancel out. So negative 4 is not going to work. So let's try negative 5. And then we'll try negative 10 if that doesn't work. Negative 5 times 1 is negative 5. 5 plus negative 5 is 0. Negative 5 times 0 is 0. 4 plus 0 is 4. Negative 5 times 4 is negative 20. 20 minus 20 is 0. So that's another one of our zeros, would be negative 5. And the way we write that is x plus 5. So again, let's see where we're at here. So this was 1x to the 4th initially, which made this 1x to the 3rd. So now we're at x squared. So this is 1x squared plus 0x plus 4. Very similar to the one we just did. So let me move myself over here. Again, I'm drawing on the video. I don't know what's happening. What is going on? This x squared plus 4 can equal 0. And we'll be able to find some solutions off of that. So we can subtract our 4. X squared equals negative 4. You square root it. And remember that 2 square roots of negative 4 would be plus or minus 2i. Now, we have all our zeros at this point. You could say our zeros are positive 1. You could say it's negative 5. And you could list these separately, or if you want, you could just list it as plus or minus 2i. And that shows you the 4 zeros there. If you needed to write it as a factored thing, you could write it that way.